Last time we were taking a look at section 2.1, which is reasoning and logic, and we had left off on talking about a couple of things that we are going to kind of conclude, and then a couple more ideas as well for today. We talked about logically equivalent. Logically equivalent means two statements whose truth values in a truth table would be exactly the same. That means like the T and F combination of items would actually look identical. And we had looked at DeMorgan's laws, and DeMorgan's laws had this sort of distributive look to them when we distributed a negation through. Ands changed to ors to ands, statements changed to the negation of the statement. Okay? And we had written this particular negation, distributing that negation through, using DeMorgan's laws. And we left off on example 4, which is us showing in a truth table that the left-hand side, that's highlighted in orange, and the right-hand side highlighted in pink, do in fact have logically equivalent truth value statements at the end. And so that's where we're going to start today, is by creating a couple of truth tables showing that these statements are logically equivalent. All right, so we'll do the orange side first. And if you'll remember, truth tables always start out the same way. They've got a column for P and a column for Q. And the column for P always says true, true, false, false. And the column for Q always says true, false, true, false. Because those are the 4 different ways in which trues and falses can be combined, and there are no others. Now, taking a look, just like with sort of algebra, we work from the inside out, and so on the inside of the parentheses, I have one more piece that says negation, so I'm going to need a column for that in the truth table as well. I need a negation of Q. Notice there's no negation of P, right? Okay, so don't put things that aren't present inside of the truth table. I don't have a negation of P. I don't need it in my truth table. So all of the individual pieces, namely the P and the tilde Q, those are my individual pieces, are now in my truth table. And I need to combine everything inside the parentheses with the statement that looks like the upside down V. Do you remember what that statement is? What does it mean? It means and. Good job. So I've got an and statement. We'll fill in the truth tables, T's and F's in a minute. So now I've got everything inside the parentheses and working my way out just one more step, I have a negation on the outside. So my last column in my truth table will include everything. It will have a negation of P and tilde Q. And this would be the last column because it includes everything. Okay? So even if you get mess ups in T's and F's, these are the pieces that are going to stay stationary throughout. You're always going to have the same P column. You're always going to have the same Q column. And then the statement you're given itself, right, this dictates the other columns that you have in your truth table. So let's fill in the remaining 3 columns of this truth table. The first one, tilde Q, means that I look at the Q column, and what do? I negate it. So trues become falses, and falses become trues. Just like that. This next column, you told me, had an and statement. This and statement is joining column P and column tilde Q. When is an and statement true? They're both true. So if there's a false on that row at all, it's false. So on row 1, where I have true, false, I have a false statement, right? There's a true here and a false here. On row 2, I have true and true, so that's true. And then look at row 3 and row 4. They're flat out false in the P column to begin with, right? So those are also going to be false. The last column says I need to negate the column that I just created. So it's just like the negation we did earlier. Falses become true, and trues become false. So the final column in this truth table is true, false, true, true. Okay, and we're going to compare that to another one over here in a minute. I'm just going to shrink this down so I have more space. All right, so our next truth table is going to be the one that's highlighted sort of in pink. Again, always going to start out with P and Q. P is true, true, false, false. And Q is true, false, true, false. Always going to start out that way. Then, looking at what I have highlighted in P, what would be my next column? Yeah, the tilde that goes with the P, right? Negation of P. What would be my next column header?
Q and tilde.
Yeah, so it'd be all of it, right? So I'll put it in the same order that I have, but if you switch it, it doesn't hurt anything. I think this one's an or, right? Yeah. Okay, so the statement would be an or statement, so I have tilde P or Q. Everything in pink, basically, the last column. All right, so now let's fill those in. Tilde P, what will the truth, false statements look like down that column?
False, false, true, true.
Good. False, false, true, true. Everybody good with that? And then my final column says to compare the Q column and the tilde P column with the conjunction that is, with the connective that is a or statement. So when is an or statement true? When at least one of them is true. So from the highlighted pink columns, on the first row, I have true, false, so that column would be true. That row would be true. The second one is false, false, which would give me false. The third one is true, true, which gives me true. And the last one is false, true, which gives me true. And take a look at this. What can you tell me about those two final columns? They're the same, right? They're the same. Hence, our statements are logically equivalent. I'm going to use the symbol since I'm running out of space, but they're logically equivalent. And so that actually proves that DeMorgan's law worked in a specific case. When I distributed the negation through as I expected it to work, it really did work. Okay, so thinking about DeMorgan's laws from an example standpoint, we have a sentence or a statement, a compound statement. And this statement has a connective in it, and or. Okay, so it is a compound statement. And we're going to use DeMorgan's laws to write the negation. So our statement says, it is not sunny, and I will go for a walk. So when you're looking at these, there are three pieces. There's this piece at the beginning, a single statement. There's the connective, and then there's my second simple statement. And I have to change all three pieces. So the first piece says, it is not sunny. We'll change to what?
It is sunny.
It is sunny. The and will change to or. That is the most common mistake right there, is to simply forget that one piece. And then I will go for a walk changes to I will not go for a walk. And that statement right there is how I feel today. It is sunny. I will not go for a walk. Not an or, though. It would be an and in my case. It's not going to happen. No walking. So, yeah. All right. There is one more type of compound statement. And that kind of type of compound statement is called a conditional. So a conditional statement is a statement that says if then. If this happens, then this happens. Sometimes it will also be, we'll read it because of the symbols we use, we'll read it as P implies Q. Another way to read it. The hypothesis is the if part. If this happens, the conclusion is the then part. Then whatever comes next. Okay, so this is harder to talk about for truth tables. I will explain why, but the chances are pretty good. When you look back at it later, you're going to be like, why was that again? It's not quite as naturally intuitive as the ands and or statements were. Just warning you, okay? So, we're going to make a truth table. Oh, I didn't tell you how it was written. I'm sorry. That's in the very first part. It's written with an arrow. So it's a P and then an arrow and then Q. That's the symbols for it. Okay, so I would use the space you have on the bottom that you just turned your page over. I'd flip back because you need that space. We're going to write a truth table. Yeah, okay? So I've got a blank slide. You just have a blank space at the bottom of yours. So we need a column for P and a column for Q, and they're going to look just like the columns we had before, okay? True, true, false, false, true, false, true, false. And the resulting column that I'm trying to show you and describe is P arrow Q. P implies Q. If P, then Q. All right? So, as a way to talk about this, I'm going to write this down as well. P is going to be the statement, I am a mom. And Q is going to be the statement, I am a woman. Okay, so what we're going to do is we're going to assume as we go through these the truth-false statements that are in our truth table. So for example, the first one says true, true. So the first one would say, if I'm a mom, then I am a woman. And that is a true statement. Right? That's true. So if I'm a mom, then I am not a woman. The opposite of that would be false. Okay, so those two are probably okay. You're probably like, yeah, of course. I mean, that makes sense, right? The next two are the tricky ones. The next two say, if I am not a mom. That's what false would mean. If I am not a mom. And if somebody comes in, walks in the door, or stands outside the door so you can't see them, and they say, I'm not a mom, and they say, then I am a woman, could that statement still be true? Absolutely. In fact, most of you in this room would be able to say that, and it would be a true statement, right? You say, if I am not a mom, then I am a woman, and it would still be a true statement, and that would be true. But if Colton said this, last column. If I am not a mom, then I am not a woman. And Colton said this. That would actually also be a true statement, right? The fact is that if we don't have the first part true, then either of the next two statements could be true or false, right? The next statement could be true or false, and all of it still works. It's the benefit of the doubt kind of thing. Right? You don't see the person at the door, so they say, I'm not a mom, but I'm a woman. I'm not a mom, but I'm a man. And you would go, okay, like I believe you. If you're saying that, it must be true, right? There is the possibility of it being true. So this is how a truth table works for an if-then statement. What I'd like for you to take a look at is that the only time that an if-then statement is false is if it's true implies false. That doesn't work. Person out in the hall that's saying that they're a mom has to be a woman. It's just the way it is. Okay? All good so far? Okay, so that's the truth table for a conditional. All right, I would like for you to take a look at how we kind of translate some of these things into language then. Okay, so we have a couple of statements. P is the statement you build it. Q is the statement they will come. Who knows what it's from? I can tell Michaela already knows what it's from because she giggled. Does anybody know what that's from besides Michaela? Okay, Michaela, what's that from? Field of Dreams, really old movie. Good one, too, by the way. I would encourage you to see that if you haven't. It's actually about baseball, and it has Kevin Costner in it? Yes. Okay. Yeah, good movie. All right, so if you build, you build it and they will come. So what we're going to do is we're going to take sentences and we're going to rewrite them in symbols. So there's these pieces, right? The way you have to start is you have to start with wherever the if is. So English is like weird. I mean, hopefully you all know that, right? Like you're comfortable with it, but anybody learning English, oh man, it's tough. And this is one of those things that's weird. We put ifs kind of everywhere. So if I say, if I'm a mom, then I'm a woman, or I say, I'm a woman if I'm a mom, it's the same thing, but I just moved it all around, okay? So the only way this works is if you start with the if, and that's the hypothesis. So if you build it, so what symbol was you build it? It's Q, right? It's P, sorry. I had it backwards in my mind. It's P. So this is P, and it says if, so that's an arrow. And then the conclusion, oddly enough, comes first, the way that this one's written. It's still the conclusion. So it's P implies Q. On the second statement, you see the if come at the beginning. It's a little bit more natural for the symbols that we're writing. If you do not build it, so what will that look like? If you do not build it. Tilde P. Tilde, because it's got the not in it, right? Tilde P. Then they will not come. Arrow, and then tilde Q. Okay. The other thing that's interesting is that there's not always the word then in them, right? If you build it, they will come is the same thing as if you build it, then they will come. Funny little English stuff, right? Okay, I think we're going to go with the other direction now. Yep. All right. Different symbols, different statements. P is the statement, God loves me. And Q is the statement, I am a sinner. So I'd like for you to take like 60 seconds or something, and I'd like for you to take the symbols that are given here and try to write the corresponding statement. So give it your best shot, and then we'll come back together and see what you have. Okay, what'd you guys write down for the first one? I see most of you stopped writing, so. Good. God loves me. That's P. The symbol that's used there is and. Oops. I am a sinner. Not only is it a correct interpretation, but it's a true statement. That's a true statement. We believe that. The next statement feels a little wonky. Hopefully you felt like that when you're writing. You were like, wait a minute, this doesn't feel right. Okay, so what is this one written down as? What's it say? Aspen, tell me what you got.
God doesn't love me and I am a sinner.
Okay, so I've got a negation. So this one starts out saying, God doesn't love me. Okay, but this one has an arrow, so we don't have an and. We need an if. Yeah, so we have an if at the beginning. If God doesn't love me, then I'm a sinner. Now, the reason it feels funny is why? Because the first part's false to begin with, right? So the rest of the statement, we look at it and go, I don't understand what it's just trying to say. It doesn't make any sense. Right? It doesn't even make any sense to talk about like that because the first part's false. So we're not talking about the truth or falseness of these particular statements, but that's why it feels weird to write it this way, just so you know. Okay, so we have one more thing that we're going to talk about here, and these are converse, inverse, and contrapositives. So we're going to take a look at the conditional form. So the conditional form for a statement was that it was P implies Q, right? That's what a conditional statement looks like. So this says statement, it's a conditional statement, all right? So if you have the converse of a conditional statement, what it means is that you turn the implication around and you get Q implies P. That's the converse of the original statement. If you have the inverse of the original statement, you don't turn things around, but you negate both of them. Yeah. So you have tilde P implies tilde Q. And if you have the contrapositive of a statement, you flip it and negate it. So this is tilde Q implies tilde P. And you're going to explore it. I think it's in the group work. In the group work, which of these four statements are logically equivalent to one another. We're going to do an example, but I want to show you an example that probably many of you have seen that applies directly to this. Okay, so we watched Bob and Larry, and they have some issues, well, at least Larry does, with contrapositives, converses, inverses, and so forth, and what things are actually logically equivalent. So let's take a look at an example about monkeys and apes and writing those statements the way they actually show up if you look at converses, inverses, as contrapositives. So when we're looking at these, this is the original statement. The original statement is, if I'm a monkey, I have a tail. And that actually works. That was probably what the zoo lady said to Larry, right? Probably. So the first one that we are going to look at is the converse. So what does the converse say that I'm going to do? Switch the order, right? The if stays at the beginning. Don't go moving your if around. It's just going to confuse things, okay? If at the beginning stays put. And we're going to switch the order around. And it says, if I have a tail. Whoops. Then I am a monkey. And that's exactly what Larry said when he saw the cow, right? It has a tail, so it's a monkey. And of course, they put the little symbol on there that says not a monkey. You saw it blinking, right? Just in case any children were confused. Second one is the inverse. So what will the inverse look like when it's written out? Again, we start with the word if. So don't get ahead of yourself. You negate it. So what am I going to negate, Hannah?
If I'm not a monkey.
Yes. If I am not a monkey. Then what? Then I don't have a tail. And again, it doesn't quite work, right? The cow actually works in that scenario as well. It's not a monkey. But that doesn't mean it doesn't have a tail, right? All right, our last one is a contrapositive. So what do we do for the contrapositive?
We'll switch and negate it.
Switch it and negate it. Still start with the word if. So if what?
If I do not have a tail.
If I do not have a tail. Then what? I am not a monkey. All right. right, so I'm going to let you explore a little bit more about which of these are logically equivalent in your group work, which is what we're headed to next.